This tutorial will show how to use Film QA Pro to scan and collect radiochromic film images. And to do this, it will show scanning of calibration films and correlation of scanner response with dose to establish a calibration function. In this video, I'm using an Epson 10000 XL scanner with a transparency adapter. And while I'll be scanning in transmission mode, everything is applicable to reflection scanning. However, it's not advisable to use reflection scanning with EBT2 and EBT3 films exposed to doses of more than about 5 gray, since the signal becomes dominated by reflection from the front surface of the film. The 10000 XL and the 11000 XL are the two scanners we recommend for radiochromic film dosimetry. Use them together with the Epson Scan software, version 3.49A with the 10000 XL and version 3.497 Plus with the 11000 XL. Before scanning for the first time, familiarize yourself with the scanner. The light source is in the cover or transparency adapter, and the CCD detector array is in the base. The cover of a 10000 or 11000 XL scanner opens away from you, and the light source, together with the CCD array, move in concert from left to right when the scan is initiated. Films are placed on the glass window in the scanner base, but avoid placing anything on the 1 to 2 centimeter area at the left of the window, as this is where the scanner calibrates the light source to set the upper end of the 16-bit range. And keep the glass clean. A glass cleaner spray is ideal for this purpose, but don't forget to clean the glass in the cover. When positioning films for scanning, you need to place the exposed areas of films along the center line of the scanner as shown in the photo. If you don't place the films in the central location, your measurements are going to suffer from the lateral response artifact. It's shown by all scanners of this type and was first described in a paper by Menegotti. More information on the subject is available in the white paper section of the Film QA Pro website. Turn on the scanner and connect it to a computer with Film QA Pro and Epson Scan installed. We leave our scanners on all the time, but if you start from cold, it's a good idea to allow about 30 minutes for warm-up. Open Film QA Pro, and the first screen should look like this. But depending on your configuration, it may have loaded the last case being worked on. So in that case, click on File and New Empty Case to start a new case. In the Case Data Selector window, that is the window on the left, click the plus sign by Case Object Management at the bottom of the case tree and click Add New Case Object to select Film Calibration Ordinary from the pull-out menu. When the object appears in the case tree, click plus to expand the object, then right-click the line Calibration Film Empty and select Scan Image Calibration Film from the menu panel. If this is the first time Film QA Pro has seen the scanner will establish communication by going through a scan cycle. Now click any of the icons at the bottom of the window and check the Twain scanner settings to see if scanner rotates image is checked or not. Click the icon to activate the scanner rotate image selection. This is necessary because on some systems the driver does not rotate the device information with the image, and the coordinate system of the image won't match the coordinate system of the display. Click again on Calibration Film Empty line and Scan Image Calibration Film, and the Epson Scan window will appear. Now check to see if the image adjustment icons are colored signifying they're active, or whether they are gray showing they're inactive. It's important that they must be inactive, or else the raw image values will be modified to provide an attractive display with all colors saturated and the brightness and contrast optimized. And for dosimetry, that's quite unacceptable. To turn off image adjustment, click on the Configuration button at the bottom of the Epson Scan panel. Open the Color tab in the Configuration window and then check No Color Correction, and then close the configuration window. The image adjustment icons are now gray and inactive. Now go to each of the cells in the Epson scan window and select or enter the other parameters for scanning. The standard set is Professional Mode, Film, Positive Film, 48-bit color, and 72 dpi. This permits scanning of radiochromic film at 72 dpi in transmission mode and produces an RGB image where the detected signal in each color channel is scaled to a 16-bit number between 0, representing black, and 65,535, representing the light intensity of the detector with nothing on the scanner. Now place the calibration films on the scanner, being sure to have all the films in the same orientation and along the central axis of the scanner parallel to the scan direction. This placement is essential to minimize the lateral placement artifact and avoid those uncertainties. Click the Preview button to obtain a preview image in the Preview window, and run Preview 5 more times to warm up the light source. Then use the Frame tool in the Preview window to define the part of the frame to be scanned in the image. Scanning just the area covered by the films, rather than the entire frame, keeps the file sizes smaller and reduces the time for Film QA Pro to calculate dose maps. This preview is included to demonstrate incorrect and unacceptable placement of the calibration films, and later you'll see what the consequences would be. Now scan the calibration film, and when the scan is complete, click on the thumbnail in the calibration object to display it in the image window. The technique of having all the calibration films in a single scan is called one-scan calibration. It not only minimizes the number of calibration images, but also uses your film and time efficiently. Because Film QA Pro uses asymptotic fitting functions that behave like film, that is, the responses approach constant values at high dose, just as the darkening of film gets progressively smaller with each dose increment, so fewer dose points are needed to correlate the specific response of a film to dose. As few as 3 points could be used, but we add 1 or 2 for redundance. A recommended way of calibration is to take an 8-inch by 10-inch sheet and cut it into strips 8 inches long by 1 to 2 inches wide, and then expose the films to known doses using a 10 centimeter by 10 centimeter field. Click on the image scaling icon in the toolbar to select scanner coordinates. The display changes to show the position of the films on the scanner, and if you scan through Film QA Pro in the Twain interface to Epson scan, the image will always contain the information of film placement on the scanner. This is invaluable when you are investigating film dosimetry problems, but the feature isn't available unless you use Film QA Pro for scanning. Now I'll show the mosaic film calibration. Start by adding a film calibration mosaic object to the case tree, and expand the new case object with the plus sign and right-click the line Data N/A Empty and click Scan Image N/A. Place the calibration film on the scanner. Again, the center of the exposed area should be along the center axis, and run a preview. Select the scan area and scan to obtain an image. Thumbnail images now appear in the case object. The top one is the image itself, and the bottom one is the mosaic image, which at this stage is no different since there's only one component. Repeat the scan process with the other films, adding the new images in the second, third, and fourth slots, etc., until all the calibration films have been scanned. By this point, the mosaic image will be tiled with multiple components. Displaying the mosaic in the image window shows the areas of interest for response measurement have already been assigned. They'll need some adjustment, but we'll return to that later. For now, let's complete the single scan calibration. Click back on the thumbnail of the one scan calibration image in the case tree, and use the frame selector tool at the top of the toolbar to draw areas of interest in the center of each film. Having drawn one frame, it can be easily duplicated. Use the mouse, hold down the control key, then point the cursor where the new frame is to go and click. In calibration, you are defining the average response of the film, so the measurement areas should not be too small. And our experience has shown that an area of about 20 square centimeters is sufficient. Now activate the calibration tool by clicking on the last line of the film calibration object. A display appears in the analysis window. So now click on the 1, 2, 3 icon in the lower right corner to populate the calibration table with all the response values in the measurement areas. Then click the dose column and enter the dose values. Note that you can enter the dose values in any order, as the doses and responses are sorted or matched in reverse order depending upon the response values. That is, the smallest dose is matched to the largest response value. By default, we use the red color channel for this synchronization, but other color channels could be used, or the sorting could be selected in matching order or turned off as needed. A detailed account of other aspects of calibration is available in the tutorial model on that subject. The dose unit in the table and calibration plot is centigrade, and the response value for each channel is a 16-bit number between 0, representing black, and the value 65,535, which corresponds to the light intensity measured by the CCD when no film is present. Right-click on the dose column of the table, or the dose axis in the chart, and specify the radiation absorbed dose unit. Right-click on any response value column or near the response value axis on the chart to change the color channel response unit. The major choices are a 16-bit value, optical density, and percent. Optical density is defined as minus log 10 of the 16-bit value divided by 65,535. And response in percent is the 16-bit value divided by 65,535 times 100. Returning now to the example with the films not in the center of the scanner. Use the frame tool to draw measurement areas in each exposure. Activate the calibration tool, populate the calibration table, and enter the dose values. Now examine the chart and observe how the points fit to the calibration function, and compare this with the calibration for films placed centrally. The data points for the centrally placed films fit closely to the function, but it is obvious that the data points for the misplaced films deviate from the function values, and this is because the response values, particularly those in the red channel, are dependent on the distance of the film from the central axis. Finally, return and display the mosaic calibration in the image window. Activate the frame selector tool and drag the regions of interest to the centers of the films, and reduce the size of one of them. By right-clicking on the frame selector and selecting Change All Frames to Selected, all areas of interest become the same size. Now activate the calibration tool, click the 1, 2, 3 icon to populate the calibration table, and enter the dose values. This example explicitly demonstrates the dose-response synchronization feature by entering the dose values in random order. And as soon as the last value, in this case 500 centigrade, is entered, the doses are correlated in reverse order to the response values in the red color channel. This concludes the tutorial on scanning. Other tutorials are available to fully explain dose calibration, dose map calculation, dose to plan comparison, as well as tools for machine QA analysis.